Hey guys, welcome back to my channel camnotion.com, and as you can see, this is part 5 solving Dibrugarh chemistry question paper 2019. And also in this video we will be discussing some of the most important topics regarding each questions. So stay connected with me, and if you guys yet not subscribed to my channel, do subscribe and hit the like button. And I'm expecting at least 10 million view hit likes in this video. So let's begin. Here we have first question. The compound that exhibits sharp bands at 3300 per centimeter and 2150 per centimeter in the IR spectrum. And we have in options given 1 butane, sorry for this is 1 butane YNE, so it is YNE, 1 butane and 2 butane, option C butyronitride, and option D is butylamine. Now IR spectrum comes in the region 3300 and 2150 per centimeter the region. Let me first draw the structure of each compound. In option A, we are given 1 butane, which have the structure like, which is just the structure is like this way. So here, as you can see, there is an acetylene hydrogen, that is an hydrogen attached with sp carbon atom. For this acetylene hydrogen atom, that is for CH stretching, that is acetylene CH stretching, we got an sharp bands at around 3300, which is just given in the question. From that we can just assume that the compound may be 1 butane. Now also it is given that 2150 per centimeter in the IR spectrum region. Also for this C triple bond C group, and IR spec and sharp bands in the IR spectrum occurs nearly 2150. From that from these two value we can assume that the compound may be 1 butane. Now let's check the other options. Now in case of 2 butane, there will be not any acetylene hydrogen will present on the structure. As you can see, this is 2 butane, and there will be not any acetylene hydrogen attached, that is any hydrogen attached with, there will be no hydrogen attached with sp carbon atom. From that there will be not there will be not any sharp bands occurs nearly at 3300, which is just given in the examination question. Now in the option C, it is butyronitride, that is, and nitrile group is present. For nitrile group, it is the region in the IR spectrum, it is not around 3300. And also in case of butylamine, the NH group stretching vibration is occurs at around 3500, at around 35 around, which is just a very high value. That is a very high value of in the IR spectrum, which is not matching with any value given in the question. So from the above discussion, we come across to a conclusion that the compound is 1 butane, because in the latter options, that is B, C, D, which doesn't resembles with any of the bands which is just given in the question. So for this question, option A, that is 1 butane, is the right option. Moving to next question. Which of the following ligands does not behave as ambidentate ligand? Now, before moving to the options, you should know what is ambidentate ligand. Ambidentate ligands are those which have more than one donor atom, That is, now in options A, where it is given that NO2, and now we know that NO2 have a two donor atom. and in NO2 or nitrogen atom also can donate to the central metal atom, and also oxygen can also donate to the central metal atom. While oxygen used to donate its electron, we will write the ligand like this way, while nitrogen is donating, we simply like NO2. For option A, it is just a ambidentate bidentate ligand. So option A is just a ambidentate ligand. Now in option 2 we have, option B we have SCN minus. Here also sulfur also can donate, and nitrogen also can donate electron towards the central metal atom. And option C, it is called thiosulfato. Here oxygen, sulfur and oxygen, both the atom can donate electron to the central metal atom, while oxygen donating electron, we used to write, we call it thiosulfato O, and while sulfur is donating electron, it is known as thiosulfato S. Now in options A, B, C, these are all ambidentate ligand. At last, in the option D, it is NO3 minus, which is not just a ambidentate ligand, which is not an ambidentate ligand, but it is a flaxidentate ligand. It is a flaxidentate ligand. So guys, you can search what are flaxidentate ligand. This is also a very important concept. Now moving to next question. Okay, so for this question, option D is the right option. Now moving to next question. Out of N2O, Clf2 minus, SO2 and I3 minus, the linear species are. Now to solve this question, we need to draw the structure of each molecule. For option A, we have given N2O and Clf2 minus. So guys, there is a minus sign. I have to apologize for the mistakes which I am making today in this video. N2O, we know the structure of N2O is N is triply bonded with N, and there is a minus sign, there will be a positive sign. Now you can solve this question in many ways, but I'm going to solve this by calculating the steric number. Now what is steric number? It is just a summation of number of sigma bonds and number of lone pairs, so this is equals to steric number. Now here you can see there is a triple bond. So in triple bond, we know there is only one sigma bond. In a triple bond, there are one sigma bond is present. Now this is also a sigma bond, so simply, and there is no lone pair present on the nitrogen atom, so simply we can say steric number of this central atom, that is nitrogen, is 2. Now when steric number is equals to 2, the hybridization of the atom is sp hybridized. Similarly, when steric number is 3, it is sp2, when 4 it is sp3, and so on. You can go with the chart which is available on internet. Now we know for sp hybridization, the structure is always linear. Now it is N2O molecule. N2O molecule is a linear molecule. Now in option A, N2O molecule is linear molecule. Now let's check Clf2 minus. Now before to draw the Clf2 minus a Lewis dot structure, you need to know the number of total valence and electrons present in the molecule. Now number of valence electron in the chlorine atom is 7, and number of valence electron in the fluorine atom is also 7, but there is a 2 fluorine atoms are there, so it will be 14, and one minus sign is there, negative sign is there, so the total valence electron will be 22. So now we can with the help of this and total number of valence electron, we can draw the Lewis structure of this compound. Cl will be the central atom because it is less electronegative than fluorine. As it is a rule that the atom with less electronegativity must be the central atom. So it is a fluorine and fluorine. Now first fill up the octet around a fluorine atom. So there will be 3 lone pair on each fluorine atom. Now if you count the electrons involved in this molecule right now is 16. Okay, now the electron left is 22 minus 16 is what? 6 electrons are still left now, which will be acting as a lone pair on chlorine atom, on the central atom, which is chlorine. Now chlorine will have 3 lone pair and two bone pair. Okay, yes, it is. Now the chlorine is not following octet rule, which is just the exception of the octet rule. And sometimes in some compounds chlorine does not follow octet rule. Now you just keep in mind that when the central atom has a 3 lone pair, when a central atom has 3 lone pair with 2 bone pairs, this is a bone pair, this is a bone pair, with 2 bone pairs, well an atom in a compound with central atom with 3 lone pair and 2 bone pairs, this structure is always going to be a linear structure. Okay, this is a rule, or you can say it's a short tricks. So in option A, N2O is a linear, Clf2 minus is also a linear molecule or linear species. So option A will be the right option for this question. For further, in option B we have Clf2 minus, which is also a linear, but I3 minus is not linear. If you can draw the structure, you will not find it is a linear structure. So in option C, I3 minus is not linear, as I already told you that. And SO2 molecule is like a water molecule, which is just a band, which have just a band shape, and it is trigonal planar molecule. And in option D we have SO2 and Clf2 minus, which is again not the right option. So for this question, option A is the right answer. Moving to next question. If the z-axis is the molecular axis, which of the following combinations is not allowed? Guys, please notice it is not allowed for the formation of molecular orbital. Now see, similar orbitals are always for the combinations. Px will always be allowed, and Pz will also allowed. So in option A we have Px and Px, so it will be allowed combination. Pz and Pz is all. This is also an allowed combinations. Now in option C and D it is S and Px and S and Pz. Now it is clearly mentioned in the question that z-axis is the molecular axis. Z-axis is the molecular axis. Since z-axis is the molecular axis, so S and Pz will can combine. That is, this combination is symmetry allowed, or you can say this will be in the same plane, or you can say same energy, that this combination will be allowed. And in option C it is S and Px. Since molecular axis is Z, so Px and S is completely will not be symmetry allowed combination. So while Z axis is the molecular axis, S and Px orbital cannot combine. So option C is the right option for this question. Moving to next question. Yeah, in a molecule of phosphorus 5 oxide. So guys, you need to know what are phosphorus oxide. It is a combination of phosphorus and oxygen molecules. So for phosphorus oxides, there is a phosphorus oxide starting from P2O, then P2O2, like dot dot dot, and there is a P4 at last, P4O10. These are the most important phosphorus oxide. And P4O10 we also call it P2O5. We also call it P2O5, which is known as phosphorus pentoxide, but the original formula is P4O10. So if you calculate the oxidation number of P4O10 phosphorus in P4O10, which will be 5. That's why in the question it is given as phosphorus oxides. They are talking about phosphorus pentoxide, that is P4O10. Now to draw, this is a very there is a very simple way to draw phosphorus oxide. Now as we know, phosphorus is exist as a P4 always in the nature. It is exists as a P4, which is just a white phosphorus. First you need to know the structure of phosphorus, which is just like this. Okay, here I am writing phosphorus structure is just like this. All the phosphorus atom connected with each other by forming 3 bonds. Okay, as you can see in the structure, they are forming 3 bonds with each other. Okay, they are connected with 3 bonds, 3 sigma bonds. Now to draw phosphorus oxide, replace each pp bond by pop bond. Replace each pp bond by pop bond is by pop bond. Now how will you draw this? This is p, this is p, this is. Okay, let me take a sharp sheet to. Okay, here I am drawing the phosphorus pentoxide. This is p, this is p, p and p. As I told you, just replace pp bond by pop bond. So here is a pop bond will be there. Here is a pop bond. POP bond will be there. Here is a POP bond. Now in middle in this bond there will be also replaced by POP bond. This is also POP bond. Now 4 oxygen has already done in the molecule, has already put in the molecule. Now 4 oxygen molecules are left, which will just combine with the lone pair present on each particular phosphorus atom. So the structure will be like this. So this will be like this, and here also P2O5. Now in the options you can see there is no PP bonds are present in the structure. There is not any PP bonds are present in the structure. All the PP bonds are converted into POP bonds. This is POP bonds, and there is if you count, there will be 12. There will be 12 PO bonds. There will be 12 PO bonds, like just like this is a PO bond. There will be 12 PO bonds and 4 P11O bonds. 4 P11O bonds and 12 PO bonds. Now let's check the options here. So in the options A, there is given pp bond, which is just not exist in the structure of the molecule. So this is just not the right option. Simply this is not the right option. And in option D also we have given p bond. This will be not the, this will also get will be not the right option. Now in option B and C, it is 12 PO bonds and 4 PO bonds, which is simply the right option. And in option C, 2 PO bonds. As you can see, there are 12 PO bonds are present and 4 PO bonds is the right option. So option B for this question is the right answer. Right answer. We're moving to next question. So guys, in this question, the expected spin only magnetic moments for FeCN CN4 CN6 4 minus and FeF6 3 minus. Now FeF6 3 minus. Now in the first molecule, fluorine is in 6 minus 4. Fluorine is in 2 plus 2 oxidation state, and in the FeF6 3 minus, F6 minus 3, it is in plus 3 oxidation state. For plus 2 oxidation state, the valence electron in the 3d orbital will be 1 2 3 4 5. So valence electron will be 1 2 3 4 5, and at last here. So there will be 6 valence electron under, that is 3d6 structure. 3d6. Now the formula is, so for spin only magnetic moment, we know the formula is n into n plus 1, n plus 2. For spin only magnetic moment, n into n plus 2, and where n is the number of where n is the number of that is what is called single electrons, that is which are not paired with single electrons present on each orbital. Now here, as you can see in Fe2 plus, there are four single electrons. Okay, so if you put the value 4 in this equation, 4 into 4 plus 2, the value it comes out to be something around 4 point something. So simply this is not exist in any of the option, as you can see. So we need to consider again a concept, that is, since FeCN6 4 minus in the molecule, Cn minus is a strong field ligand. Now in the environment of strong field ligand, the electrons of central metal atom is just paired up, so the structure, the orbitals, the electrons in the orbital will like to be paired up. So 3d6 can be all the 6 electrons in 3d6 orbital will be paired up, and there will be not any single electrons present in the orbital. So simply putting 0 replacing 0 by n, so we will getting option 0 is the right option for the magnetic moment for FeCN6 4 minus will be 0. So in option C and option D we have 0 uh, 0 Bohr magneton, and also we need to calculate the magnetic moment for this compound also. Now here Fe is present as 3 plus. Okay, so there will be 5 valence electrons, that is 3d 5 will be the structure here, 3d 5 will be the outermost electronic configuration. So 3d 5, and so this is the structure of 3d 5. Okay, so this is the structure of 3d 5. Now if you there will be 5 valence electrons, so if you calculate for it, you will get the answer is D. Option D is right option. So moving to next question. Okay, this question is here. A compound has empirical formula COCl3 5NH3, which an aqueous solution of this compound, when an aqueous solution of this compound is mixed. So aqueous solution of this mixer, that is COCl3 dot 5NH3, this is an empirical formula, and we take the aqueous solution of this compound and mixed with excess of silver nitrate solution AgNO3, and 2 mole of AgCl precipitate out per mole of the compound. So if for 1 mole of this compound we will get 2 mole of AgCl. That is, this is very simple question. On reaction with the excess of HCl and NH4 plus is not detected. This is a key point here. NH4 plus is not detected. Now see, in the options, this here CONH35Cl and Cl2 is the, so if you dissociate this molecule, if you dissociate this molecule, that is you will get 2Cl minus, okay, 2Cl minus ion, and this the rest part will be in the ionic pair as 2 plus, that is here will be 2 plus and here will be 2 minus. Okay, that is Cl2 minus, okay, 2Cl minus, sorry. So in option A we have in option A, if you ionize this compound, you will be getting 2Cl minus, which is just available to react with AgNO3, and we will get 2 moles of AgCl as a precipitate. So to get 2 moles of AgCl precipitate, we need to have 2 molecules of Cl minus ion in the mixture. This is a simple logic. Now if you check the rest options, there will be not, and you will not get any in any options that 2Cl minus will be ionized out, because there will be only one Cl present in at outer will be ionized out, and here also no Cl is present, as we have as we are as it is given in the option dash. NH4 plus is not detected, so option A will be the right option for this question. Now moving to next question. Select the correct order of CO bond length. So simply I am telling you the concept here. As you can see, in all the options CO3 is there, molybdenum with CO3 is there. Now CO bond order CO bond order will be increased when metal start pushing electron, which is called back donation, starts pushing electron to to now this is C double bond. Oh no, okay. Well, this is a back donation call, back donation, which is just and which is just a donation of a metal non-bonding electrons to the empty to the empty orbital of the carbon atom. This is called d pi p pi back bonding. So if the electrons are available on the metal atom, then it will donate its electron to the MC bond order, MC bond, which simply decreases the CO bond order. Okay, which simply decreases the bond order when metal is when electrons are available on the central metal atom. Now as you can see in the options, PF3 is present, PCl3 and PMe3, PCl3, PCl3 and PMe3. Now PF3 is a pi acceptor. Because of these pi acceptors, MO molecule will have slightly less electron will be available than this molecule, and at last we have PMe3 molecule, which is in which metal atom will have access of electron to donate into this bond, so that C double one O will have the least bond order. That is, least bond order means it becomes weaker. Weaker bond, and as we know, weaker bonds have a larger bond length. So option C, it is the right option, because here CO bond length will be larger than a PCl3 than PF3 molecule. So for this question, option C is the right option. Moving to next question. Yeah, the complex which exhibits the lowest electronic absorption band. Now to solve this question, you just check the options. That in all the options there is these are all nickel compounds. This is NiCl4, NiH2O. Sorry, this is a 4 will be there. NiH2O4 and NiCN4 and NiCO4. Now you will notice that in all the options, the ligands except A, the ligands are strong field ligand. That is, Cn minus is a strong field ligand. CO is also a strong field ligand. And if you go to the electrochemical series, you will find water in the middle of the region, or sometimes it is considered as a strong ligand, and it is just an intermediate. You can say it is not a weak field ligand. But Cl4, this is a weak field ligand. So due to the presence of weak field ligand, this particular molecule will have CFSE, that is crystal field stabilization energy. That del will have lower del value, that is splitting will be very low. In this particular molecule, the nickel atom will have very less splitting will be there, so it will absorb at the lowest electronic absorption band. So this molecule will exhibit the lowest electronic absorption band because of the very narrow splitting due to the presence of weak field ligand chlorine. So for this question, option A is the right option. So this so guys, this is the last question in this video, and the further questions I will try to cover in my next videos. And guys, if you like my video, if you like the video, if you like my explanation, do subscribe and hit the like button. And thanks for watching.